Hi there, one last example for this, and it's using the binomial distribution. And the reason we're going to do the binomial distribution is because um, our sample size is going to be too small, so we can't assume normal. So here, if we look, if n times p times 1 minus p, I'm right up here, is less than 10, then the distribution of the sample proportion p hat is not approximately normal. So in this situation, we're going to use the binomial probability formula from section 6.2 to test our hypothesis when we have small samples. So here we have 4% of mothers smoked more than 21 cigarettes during their pregnancy, and obstetrician believes the percentage of mothers who smoke 21 cigarettes or more is less than 4%. And that she selects 120 pregnant mothers and finds that 3 of them smoked 21 or more at a level of significance. What am I doing? Wait, hold on. 21 or more. Does the sample data support the obstetrician's belief? And we want to use a level of significance alpha of 0.05. So first of all, we're going to find our null and alternative. So our null hypothesis here, if we look, 4% of mothers smoked more than 21 cigarettes. So our proportion is going to be equal to 0.04. That is what we're going to assume is true because that's the data that we currently have. Our our alternative hypothesis is the idea that the obstetrician had. She believes the percentage of mothers who smoke 21 cigarettes or more is less than 4% today. So here we're going to do an alternative hypothesis that the population proportion is less than 0.04. So if I go through and try to look at my conditions, right, my second condition is to see if my sample size is bigger than 10 or not, larger than or equal to 10. And so here I have a sample size n equal to 120, and I have a population proportion for my null hypothesis of 0.04. So what I'm going to do is 120 times 0.04 times 1 minus 0.04. And if we go through that, what we find is that equals 4.608, which is definitely less than 10. So we are not normal. We can't assume normal. So here what we're going to use is the binomial distribution. Okay. So we're going to go ahead and use the binomial distribution if you think back to chapter 6.2. So let's take a look at that. And what we can do is here, remember, we define things in a binomial distribution as success and failure. And oddly here, success is going to be if you smoke more than 21 cigarettes a day. And failure is that you don't smoke more than 21 cigarettes. So again, remember that that doesn't have to match up with what we consider positive or negative. Okay. Per day. That's a lot of cigarettes. Okay. So then what we can do, and if we look here, there's an error on this page. So this should actually say, let's cross the whole thing out. We're going to use the probability that 1 minus the probability that P has an X value of greater than 3 here. So in this case, what we're doing is we're wanting to see what's the probability. Well, let's write down some things. We have an N of 120. We have a P value for our population per our null hypothesis is 0.04. right? And our actual data shows that we have an X of 3 because we have 3 people that smoked that much out of our sample size of 120. So what I'm looking for my binomial distribution is the probability that X is less than or equal to 3, because that will tell me if I had 3 or 2 or 1. If I think about what this distribution looks like, let me draw it kind of small. What I'm looking for is if I'm over here, right? Because I'm probably skewed somehow. All right, and it's because I'm little, and we'll take a look at the distribution actually in a minute. So I'm looking for the probability that it's less than 3, and that largely comes from here, where my alternative hypothesis is less than, okay? So if we go to StatCrunch again, we can go into StatCrunch. Oh, I didn't close that one. I can go to Stat and to Calculators. I can go to my binomial calculator. Remember this one where it shows me the binomial distribution, which is why I didn't draw it. So here I'm going to input an n value of 120. I'm going to input my probability as being my null hypothesis probability, which is 0.04. And what I want to know is what's the probability that I have 3 or less people out of that sample of 120 that smoke 21 cigarettes or more. So if you look at the distribution, you can see that over on the right-hand side, it seems to kind of trail off over there. It's a little bit skewed. And so if we look at the probability there, what you see is the probability that it's less than that is 0.2887. So if I come back over to where we were, this is 0.2887, which is equal to my p-value. Okay, and so we'll note that this probability is my p, or my probability is equal to 0. I'm going to use p-value there just so you're not confused. Probability that x is less than or equal to 3 is 0.2887, which is greater than 0.05, which was my alpha value, right? Which is actually what I'm doing down here, I guess. And so when I compare those two, what I find is that I fail to reject my null hypothesis. So here I would fail to reject. Again, if I wanted to write that out, we could say that we failed to reject the null hypothesis. There is not evidence. So there is not evidence to reject the null hypothesis. So we cannot conclude the proportion of pregnant women who smoke more than 21 cigarettes per day has decreased. Okay, we can't conclude that. We don't have a statistically significant result. So I think that does that. That's just a little one to kind of show you what to do if you have a binomial distribution. Um, and you can't assume normality from here, um, so that you can kind of see what you would do. And it's kind of tying back into chapter 6, so I think it's helpful for you to see. So I think that'll do it for the things on the population proportion. I'm going to do maybe 1 or 2 examples that should be short on hypothesis testing for sample means, and then you will be good to go. So we're just kind of tying everything up. We're using the information that we've already learned and putting it together so that we can determine whether or not things are changing. Okay, and that's what we do when we do studies. So let me know if you have any questions, and I'll see you soon.